Hi everyone, let's talk about the Friedel-Crafts reactions. So Friedel and Kraft were a pair of scientists which came up with a set of reactions which involves a benzene ring and a alkyl halide. So in the first reaction, the Friedel-Crafts Acylation, they started out with benzene and reacted a primary alkyl halide. So what they found was an isopropyl benzene product. The mechanism for the reaction lies in the aluminum 3-chloride catalyst. So what happens is the reagent 1-chloropropane reacts with aluminum 3-chloride and produces a propane cation in which the positive charge is on the secondary carbon as opposed to the primary carbon, since a secondary carbocation is more stable than a primary carbocation. And aluminum trichloride just holds on to the chlorine, which gives it a negative charge. So at this point, our benzene is going to extend its pi electrons and coordinate with the secondary carbocation, leaving a positive charge about this carbon and some base. It could be the aluminum tetrachloride, which we just produced, is just going to deprotonate this hydrogen, and we'll just have an elimination reaction in which we get the product. So the next reaction we're going to look at is the Friedel-Crafts acylation. So just like the alkylation, the aluminum 3-chloride is going to play the same role as a catalyst, which we saw here, except with our acyl halide. So just like in the alkylation, this chlorine here will be added to the aluminum complex, which, if you look here, will give our carbon only 3 bonds, and carbon again wants to have 4 bonds. It always wants to have an octet of electrons. So what will happen after our chlorine leaves is these pi electrons will come down to form a triple bond with this carbon in order to achieve that octet, and we'll be left with something called an acylium ion, where our oxygen actually has a plus charge, and of course our aluminum tetrachloride ion. So with our acylium ion, we also have a resonance structure where the carbon doesn't have the octet, and these pi electrons go back to the oxygen. We're going to have a double bond to the carbon bound to that methyl group, and thus a positive charge on the carbon. If there's a positive charge on a carbon, that means that it's an extremely strong electrophile. So from our benzene ring, we're going to get our pi electrons coordinate to this carbocation, and the same elimination reaction will occur right here, where the base, which is our aluminum tetrachloride, will deprotonate the hydrogen, pushing pi electrons back to the benzene ring, and ultimately forming our product here. I hope that helps. Thanks for watching.